So what I'm going to be sharing with us this evening is just an addition to what we've been doing all this while. If you notice, when we first started, we start. So if you notice, when we first started, we create a database, we create a table, we insert, as in insert data into our table, we populate our tables. But what I'm going to show us this evening, part of what we've been doing, we are the one to key in the ID for some of the data we've been keying in, or some of this data we've been inserting into our tables. So I want to show us this, that we can actually automate it. We can actually automate it. We can actually ask Postgres to do that for us. In my SQL, we have what we call auto increment. The moment you initiate auto increment, then the guy will help you to keep increasing the IDs, the IDs. Then in Postgres, we have what we call serial. Serial. The moment you select serial, it could be serial, it could be big serial, it could be small serial, which is a family of integer. So it's going to help you it's going to help you with your ID. So you will no longer be the one key in IDs for your records. And that helps a lot. If you are the one keying IDs for all your records, mistakenly you can key in 2 IDs or same ID for 2, 3 or more people. Human error. But if you do that without, at times, okay, except you initiate primary key, except you apply primary key on your table, that's when primary key will help you and tell you that, oh, error, that the ID you are making use of has already been used. But let's assume that you did not put primary key on your table, so you can mistakenly use same ID for more than one person on your table. But if you initiate this big serial, it could be big serial, it could be serial, it could be small serial, depending on the size of the table, depending on the size of your table, then it's going to help you. So that's one of the things I want to show us this evening without wasting much of our time. So let me just, this guy is up already. My PG admin is up already. So let me just, I'm going to create a new table inside that, the first database we created earlier. So I'm going to create a new table in there using query tool, and I'm going to populate it at the same time. So I have one file here. So this is the statement for the database, but I'm not going to use that. All I want to do is, we have a database running, so I just want to create a table inside this database, and this is the statement we'll be using to create our table. So we have create table teachers. Create table teachers. Then the ID will be big serial. Big serial is like a big int, because By the time we run this code, big serial is going to be converted to big int. It's going to be converted to big int. Then it will help us to automate the input of our ID. Okay, so we have big serial, we have first name, varchar. Varchar is still the same thing like variable character. Then last name, variable character. Then school, variable character, hire date, then salary, numeric data type. Okay, so I'm going to run this. How many columns do we have? 1, 2, 3, 4, 5, 6. 6 columns. So I'm going to run this. Okay, good. Query returned successfully. So let's check the table out. So this is a table, teachers. This is a table. We have teacher. So let's check the column out by using a select query. Select all from teachers. Okay, so let me run this guy. Now, if you look at it, you see that our column ID has changed to big int. The data type there has changed to big int, while the variable character has changed to character variant. So in some other databases like SQL, like my SQL server, it makes use of variable character, and Postgres as well understands variable character as a data type. So Postgres calls its own character variant. So it identifies variable character as character varying data type. Okay, good. So the next thing we want to do now is want to populate our table, our teachers table. Want to populate it. I have some inputs that I've written here. One insert statement and some data I want to insert. Now, because we ask Postgres to help us to key in the ID. So this is what we are going to do. When you write your insert statement, insert into teachers, you specify your columns. You specify all your columns, aside from the IDs column. If you notice, I did not include ID column. And the reason is being that I want Postgres to do that for me. Okay? If I did not ask Postgres to help me with my ID, I will have included the ID column. Okay? And if you notice from the values I'm keying in, I did not put ID. There's nothing like ID in there. If you check all of them, there's nothing like ID in all of them. There's nothing like ID. Okay, I did not put salary for this guy. So let me just put it like that. Okay, beautiful. Now, if you notice from all the values, I did not key in IDs. I did not key in IDs for all of them. So I've told Postgres to help me manage the IDs. I've told Postgres to help me manage the ID. So that's why I did not include ID column. So let's run this statement. Let's run this statement. Insert into teachers. I specify all the columns. Then my values. Okay, so let me run it. Beautiful. So 7 columns inserted. So let me check what we have in there. If you notice, look at it. Postgres has helped me to put as into keying IDs, to keying IDs for them. Has helped me to key in IDs for all of them. Can we all see that? Beautiful. Any question? Do you have any question, please? Hello?
Please, can you run it again?
Following.
Yeah.
Okay.
Okay. What's the question, please?
So please, can you go back again?
Okay, okay. What I'm saying is this. I'm trying to create another table to show us how we can ask Postgres to help us with the IDs. Because human error, we may mistakenly key in one ID for two people or more people. Human error. So I'm going to use a data type called big serial. We have three of them. We have big serial, we have serial, we have int. Sorry, we have small serial. And all of them, they are converted to, they are family of integer. They are family of integer. The big serial will be converted to big int, while serial will be converted to int, and small serial will be converted to small int. Okay, so I ran this query to create a table called teachers, and this is my insert statement to populate my table. And when I'm writing my insert statement, because I've asked Postgres to help me with the IDs, to help me to automate the input of the ID or the insertion of the IDs. So I will no longer, I won't include the ID column when I'm writing my insert statements, when I'm populating my table. So I will exclude the ID statement, and that's why I did not include the ID. I completely removed it because I've given that task to Postgres to help me with. Okay, and this is my insert statement. Insert into teachers, first name, last name, school, hire date, and salary. Then these are the values are inserted. Values, Janet Smith, that's the first name, the last name, the name of the school, the hire date, and the salary. Okay, so, and when I run it, Postgres helped me with the IDs. Postgres helped me with the IDs. Okay. Any question? Can I move on? Hello?
Yes, sir. Yes.
Okay. Let me go ahead. Let me go ahead. Now with this, I think I wrote something down here. Okay, good. I have something here that we can do what we call data exploration. Data exploration with select statements. That is the best part of digging into data, isn't the prerequisite of gathering data, loading or cleaning of your data. But when you actually get to interview your data, those are the moments when you discover whether the data is clean or dirty. Okay, a simple statement, a simple select statement can help you filter all your documents, filter your data, filter your record, can help you to retrieve everything in a single table, like we did here, like I wrote select all from the table teachers. And he did what? He brought out everything we have inside that table called teachers. He brought out everything we have in there. And at the same time, we can do a whole lot with select statements. Last class, I showed us how we can make use of where clause. How we can make use of where clause to help us filter our data. Okay. Select all from teachers where salary is greater than 45,000. So this guy will select everyone that their salary is greater than 45,000. It's going to help us. So let's see. Let me run it. You can see these are the people that their salary is greater than 45,000, and we just have two of them. We have Lee Reynolds and Fela Ransom. Their school is FD Roosevelt HS and Maryland Comprehensive High School. So with the help of the select statements, we're able to see the person that has the two people that their salaries are greater than 45,000. Okay, it's part of filtering your records. Okay, then and at the same time we can still do select max. Select max salary from, okay, let me do select ID, first name, last name, max salary from teachers. I hope this guy allowed me. Okay, I know it's going to trigger this. I know. Max salary. What's the issue? It's telling me syntax error near this. Okay, what's that? Okay, hold on. I know. Next max salary and first name of the person. Should be able to go. Okay, small. Okay, group by. But it's just one person. Why are you saying? Why is the same? I didn't do what I asked you to do. Okay, we group them and rearrange the salary in ascending order. No, even this one is not even ascending order. So we want to do ascending order, we have to ascending, that's descending. Okay, let's see. Descending max salary. Okay. Same this. Sorry, hold on. Are you seeing this? By this. Okay, sir, we can stop here saying select all from teachers, and we put a full stop. And the query the statement will query our database, and it's going to give us everything, as in everything. But when you want to narrow it down, we don't want everything inside the table. So we are giving it a condition that though as much as we want the query to return all the columns, we don't want all the records. Though we want all the columns, but we don't want all the records. Okay? Yes. And what is the condition we are giving this guy? We want you to return to us all the columns of the people their salary is greater than 45,000. Did you get it, sir?
Yes, sir.
So, and it's going to streamline that and give us all the people that their salaries are greater than, you can see. And we can as well narrow it down by saying, okay, we don't want everything, we want ID and first name alone. Okay. Then you should just give us their ID and their first name. Okay. So that's how to use our select statement. Select statement is just to view, to filter. What if you want to filter it, then you use where clause. That is like a condition. I want this, but this is a condition. I don't want everything. I don't want you to jam-pack my query or the output. I don't want to see everybody. You get it's like when you have a whole lot of people in your database and you just want the people that belong to a particular age category, maybe teenagers. So it's going to be select, so pressing where the age is, maybe the age is let's say from 13 to 19. You just say between 13 and 19. That is, the age is greater than or equal to 13, less than or equal to 18. No, sorry, less than or equal to 19. Then it's going to give us. Okay, we can let's try that here. The salary between 45,000 and okay, let's say 25,000 and 65,000. Oh, this guy, what? You can see these are all the people that their salaries are between 25,000 and 65,000. So if you make it, if you jack it up a bit, between 35,000 and okay, 7 of them, their salaries are between 25,000 and 65,000. So let's jack it up a bit by filter it a bit. Say between 35,000 and 65,000. Let's see how many. Okay, we still have 7. So let's make it between 40,000 and 65,000. You can see that the number has reduced. Filter it down a bit, narrow it down. Then if you make it between 50,000 and 65,000, you can see we only have just one person, Lee, that has between 50,000 and 65,000. And we can as well do it like this, where salary is greater than maybe 35,000. You say greater than or equal to 35,000. That means it's going to start from 35,000 upward. You can see all of them greater than or equal to 35,000. If you say greater than or equal to 45,000, you can see reduce it. Okay.
Okay. Okay.
I want to believe you. Okay, I'm listening. Sir.
This nice statement, the one on line 11.
Line 11.
Yes, run it again, sir.
Okay. Let me run this. Okay, I have this guy twice. Sorry, I was wondering why it was giving me. Okay, let me run this. See. It's giving us their salary and their first name.
Now, the question I want to ask.
Okay, sir.
What we put as maximum salary?
Okay.
So I don't know. What do you mean by maximum salary?
Okay, now what I wanted to do initially was for this guy to bring out the maximum salary from the old teachers. You can see this is the highest salary. That's what I mean. This is the highest salary. So I'm trying to see if I can get the first name of the person with highest salary, maximum salary. Okay, it's telling me.
This has led us to the next question I wanted to ask.
Okay, what's the next question?
You know what you did, the last one was to not say group by.
Group by, yes.
Why are we grouping? What was the function of that grouping?
Okay, now, the thing is this. If you have
Sorry, sir, before you explain, I'm listening. You know, there is something you normally read from this error information given to us.
Okay.
So how you normally do that for us to know that, okay, if we do something and we have comments talking about the error, how we interpret it and we adjust.
Okay, good, beautiful. Now, this guy is like Excel too. He's very smart, except if you don't know how to study this guy. You can see it's saying error. And what is the error? Column teachers.first name. That is, the first name column from teachers table must appear in the group by clause or be used in an aggregate function. Did you get it, sir? We are using, this is what we are using. Maximum salary. Yes. And maximum salary will only give us just one value. We cannot have two maximum. Abi, we cannot have two, we can only have one. As long as that's the highest, we can only have one. So it's now telling us that if you want to pick the first name, that means the first name will have to appear. You have to group it. And when I'm grouping it, it will not only give me the maximum salary. It will only arrange it. It will give me the highest salary. Then it's going to list other ones, like he did the other time. If I say group by first name, now it won't just come out with just one, but you can see, sir. It won't just come out with.
I mean, it's not come in.
You understand? So you will now group all of them and give me their name, their salary.
No. Oh, sorry, sir. Okay, to bring all the information back again.
Yes, on all the information back again.
Okay, that means instead of using max salary,
okay,
maximum salary, since I know it will still return all the information back to me.
Okay, sir.
I can decide to use another statement.
Okay.
By using maybe to arrange the ascending order.
Now, if you are doing that, we now say, okay, yes, we can do that. Then we can now say group by this guy, order by max salary. So when you order by max salary, let's see what this guy will give us. Then we can now use descending order. So he's telling us, okay. No, I don't need to do comma. You can see. Now it's giving us in ascending order. So if I want it in descending order, I will just do DESC. Then this guy will give us in descending order. You can see, sir.
Yeah.
So when you are talking about values, okay, I'm listening. What is this something?
Okay. Now with this, oh no, this statement we have now.
Okay,
you know,
sir.
This descending.
Yes.
No, it's possible, sir, for us to bring it here under max salary, the first max salary.
Here.
That's select first name, descending.
It's not going to work.
Salary.
It won't work.
Okay.
You know what we are doing now is this. We want this guy to give us first name.
Yes.
And maximum salary. Or
yes.
in fact, what we ought to have done, if we want to see all of them, we ought not to have requested for maximum salary.
Okay.
You get that? We should have said, just give us salary. Okay? Yes. Give us the salary, order by salary, in what format? Descending order. If it's giving us in descending order, then we can see from the top. The very first one is going to give us will be the maximum. I think that's the best way to have written it. Okay, it's telling us something. Salary must appear in the group by blah, 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 blah. Okay. No problem. If you want us to have it like that, let's see. Sorry. This lights. Okay, salary must appear in the group by clause. Okay, let's see. You can see, sir. So now the guy is arranging it. But if you want the maximum value, sorry, if you want the okay, I'm with you. Okay, sir.
Yeah. The error statement salary must appear.
Yes.
In the group
by.
Then how did you know that this is where to put that salary? Because you just put salary before that.
Okay. Now the guy. Okay, let me remove it. And let me run it again. Now the guy is pointing at something.
Yes.
You get that? Say yes, column, that is salary column in teacher's column must appear in the group by clause. He had seen it that we are using group by clause.
Okay.
I didn't mean we only have salary alone. He will have asked us to use salary column to group it. But we have first name, and we are using first name to group them.
Yes.
So he wants us also to use salary column to group it. And since we are using the two of them to group it, so we just separate the two columns by comma. And that's exactly what I did by putting comma like this and run it.
Okay.
Then because I put order by salary descending, so it's going to start from the highest. So if I did not put descending, it will start from the lowest.
Okay.
It will start from the lowest. So the moment I put descending, because we may have lots of them, we may have it in thousands of rows or hundreds of thousands, and we want to get the maximum or the highest. So plus the name of the person that earns the maximum salary. So we just put descending order and ask for the person's maybe first name or something. So then it will first of all show us this. Are we good, sir?
Yes, sir.
Okay.
Thank you,
So maybe what I would do is this. After the class, I will send us these notes.
Okay.
I will send us these notes. I will send it to the group, so we can practice. Then I have exercise there. So I want us to practice it, to practice the exercise. So we just run all these statements. Then I'll be asking us questions. So I have written some SQL statements there. You can just copy it, put in there, and you see how it works. Okay. Then another thing I want us to check is this. There is what we call distinct value. Distinct value. So let me use that. Select distinct school from teachers. Now I'm going to remove distinct. Okay, let me just do it this way. Select school from teachers. We notice that when I used distinct, you only gave me how many schools? Just 3 schools. And I know that we have more than 3 schools, as we have 7 rows. So let me say select school from teachers. Now we have how many? It returns 7 rows. It returns 7 rows. So why did this guy reduce the number of schools that we have in there? Distinct can only return just a unique value. It will only return a unique value. It's not going to return one school twice. Like this guy now, Roosevelt High School appears 3 times. 1, 2, 3. It's only return it once. It's only tell us when we use these things. It's only return it once. Because it's still the same thing, though it appears 3 times. It's still the same thing. Then Mayor's Middle School appears 3 times as well. It's only return it once because it's still the same school. So distinct keyword in SQL will return a distinct value. Sorry, it will return a unique value. It's not going to return a value twice. If one value appears, if one data or record appears like 5 times, it only return it once. To return it once. I think I have some query like that here. Okay. Okay, I've run this. So let's work with this. Let's see this. Let's see what this guy will give us. Now, before I use this, so before I put these things, let me run this statement. Select school salary. Now, it returns 7 rows. It returns 7 rows. But by the time I include distinct, it returns what? 6 rows. Can somebody tell me what happened? Hello? Hello? Hello?
I think one has salary.
Sir, I didn't get you, sir.
The first one is just select distinct school from teachers.
Okay.
Why is the second one? So select distinct school comma, then salary.
Okay.
From teachers.
Okay.
So how I think the salary is what changed it, but I don't know, sir.
Okay, okay. You got it. You got it right. Yes. Salary for all of them, for this guy to return a unique record. Everything you have in the air must be the same. If you look at row 4, we have Roosevelt High School, and the row 5 too has the same thing, but different salary. Different salary. If they have the same salary, like this Mayors Middle School has 36,200, and this guy too has 36,200, is going, and it's the same school. It will just pick one. It will just pick one. So let me do this. Let me remove school, and let me remove this these things. Select salary from teachers. Let's look at that first. We can see all the rows, and we know that some salaries were repeated. Some salaries were repeated. So let me include these things. Now we have 7 rows. So let's take notes. You can see we have how many rows now? Just 5 rows. So the ones that are repeated has been taken off. I know 36,200 was repeated twice, and 38,500 too was repeated twice. So he knocked them off. He did not repeat them. So these things will return unique record for you. To return unique record. In a situation whereby we have 10 people bearing the same first name. 10 people bearing the same first name. And we now say, select distinct first name. It will only return just one first name. It's not going to repeat all of them, except we say, select distinct first name, last name from the table. Then, because they are bearing different last names, so it can now return all those first names. Okay? Did you get that explanation?
Yeah.
Okay, thank you. So we can always make use of, I will send these notes, then we can always work with all those statements that I have in there. So let me move on to the next one. Comparison and matching operators in Postgres. Comparison and matching operators in Postgres. We have operator function example equal to, greater than or equal to. This sign, the greater than and less than and greater than, is the same thing as not equal to. Is the same thing as not equal to. Okay, like we used in Excel. Like I think yes, in the last Excel class, we made use of this sign to represent not equal to in one of the stuff that we did. Then we have this symbol greater than, where salary is this, is greater than this, less than, where salary is less than this, greater than or equal to, where salary is this, less than or equal to, and all of that. Then between, I think we ran this, we ran all this, we ran this, but we did not do this. So let me work with this. This not equal to. Okay, one of our schools. Let me check one of our schools. Select school from teachers. So I'm going to run this again. Select school from teachers, where school not equal to, okay, let me do FD Roosevelt HS. think I need to quote it. It's a string. No, shouldn't be. Still returning it. Okay, let me do this. Let me use the other symbol. Not equal to. Still returning it. It's not supposed to return it. So still returning that. It's supposed to. Okay. I know what to do. Where school not no, it's going to trigger an error. This guy is very sensitive. So whenever we are typing anything, it has to be exact way it is in your record. It has to be the exact way it is in a record. If I type this guy in lowercase, it's not going to say it. Okay, sorry. If I type this guy, if I type FD in lowercase, it's not going to say it. You can see it won't say it. So it has to be the exact way it is in the record for that to take effect. So let me try the second function, which is not equal to symbol. It worked, because I know it should work. So when we are querying our database, we have to be very sure of the correct spelling of what we are requesting for when we want to query, what we want to retrieve from our database. Okay, good. Then we have another thing, what we call in. Match one of a set of values. Match one of a set of values. So we can have something like select all from teachers where salary in or where name in. Where do I have that? Okay. Select ID first name from teachers where salary in, that is within this. Okay, let me see. Let me write 20,000. 60,000. Think. Okay, that means you don't have any salary within this range. You don't have any salary within this range. So let me put 65,000. You can see we have Lee within this range. We have Lee. So if we have just Lee within this range. So let me put, I think we have 45,000. I can't remember what we have in there. Okay, we don't have anyone within this range. So that's how to make use of the in, just to show the set of values within a particular thing, within two ranges. Then we have like match. Like match a pattern. That one is case sensitive. The like match, it's case sensitive. Then I like is case insensitive. What do I mean by case sensitive and what do I mean by in case sensitive? The case sensitive is, it has to be the exact same way. It has to be the exact way the stuff is written. Why the other one, I like, doesn't care. whichever, if you like, put it in lowercase, if you like, put it in uppercase, it's going to pick it. Okay. I think I wrote one statement like that in okay, I think like this, something like, okay, yeah, this one. Select first name from teachers where first name like this, that is like this. We call something wild card in SQL. We call it wild card in SQL. So that is anything that has Sam. If you have anything in your record that has Sam, it's going to bring it up. Select first name from teachers where first name like. And this guy, because like is case sensitive, you can see the guy is not going to give us anything because it is case sensitive. Because it is case sensitive. If you run this, let me just run this. Select first name from teachers alone. You can see we have Samuel, we have Samantha, and it's because we have them in capital S. We have them in capital S. That's why I did not return it. So let me change this to capital S and let me run it. You can see, brought them out. Brought them out, Samuel and Samantha. But if we do I like, and we put this Sam in lowercase, I like is case insensitive. Hello? Hello?
Hi. Hi.
It's looking as if we are performing magic, right?
No. Sorry. Is the white card the percentage symbol?
Yes. The percentage, it says that the first three letter,
okay,
of a particular record, irrespective of what it has at the end.
Okay, sir.
Irrespective of what it has at the end, the first three letter must be SAM.
Okay.
And that's why he gave us Samuel and Samantha. From that,
sir.
all this stuff that we are doing as a data analyst, we are not meant to be going through all this stress. I'm just like, okay, let me just give it to us, show us this. Okay. As a data analyst is to query the database, pull a record, and analyze it. We are not meant to be doing all this. But like I said, I will send us this file. I will send us this file. Then we can run all this query and all of that. I put some notes there, and I think it's well self-explanatory. So the difference between like operator, which is part of ANSI SQL, which is the standard SQL, is case sensitive. Why the I like operator, which is a PostgreSQL only implementation, is case insensitive. Like all these vendors, they always try to customize things. Okay, this is me, this is my product, and this is what I want to. I want this to be peculiar to my product. I want this particular thing to make my product unique. So you can only do this within my product. Okay, this I like is peculiar to is Postgres implementation, and it is case insensitive. Okay, so what else do I want us to? Okay, we can as well do this. All statements and statements, the logic operators in SQL, we can implement that too in SQL. select all from teachers. Select all from teachers where last name equals to Cole or last name equals to Bush. Okay, that means the two of them. The two of them, we have Cole and we have Bush. So in a situation whereby Cole does not exist, then it's going to give us Bush. Okay, in a situation whereby Bush does not exist, it's going to give us Cole. So that's the essence of the or statement. But in case of and statement, the two of them must exist. Okay, like this guy now, like this next statement I'm going to run. It says select all columns from teachers where school equals to FD Roosevelt High School and salary is greater than, sorry, salary is less than 38,000 or salary is greater than 40,000. Now we have two conditions. The school must be equal to FD Roosevelt High School and the salary must be within this range. It's either the salary is less than 38,000 or the salary is greater than 40,000. So the two conditions must be met. The two conditions must be met. Okay, beautiful. Now we have salary less than 38,000, which is 36,200. And we have salary greater than 40,000, which is 65,000. And the school is what? FD Roosevelt High School. Hello? Okay.
We are with you, sir.
Okay. I know you are with me. Now, I have exercises here. Just 3 of them. It's just for you to practice. And if you want me to look at it when you are done, no problem. So the first one says, the school district superintendent asks for a list of teachers in each school. Write a query that lists the schools in alphabetical order, along with teachers ordered by last name A to Z. That's the first one. Then the second question says, write a query that finds the one teacher whose first name starts with the letter S and who earns more than 40,000. It's straightforward. Then the third question says, rank teachers highest in January 1, 2010, ordered by highest paid to lowest. Can we do that? Just practice. Just practice. It's just for you to work with.
Okay? We attempt it, sir.
Okay. Yeah, good. Then another thing I want us to do during the course of the week, I'm going to send us a video. You know, I told us the other time that we have 3 different ways of importing data, or 3 different ways in which we can populate our database. We did the first one by using, by importing the sample database DVD rentals into our Postgres. The another one is by using SQL statements, query SQL statement. I will try and look for that, probably send it to us. We can import that too. Then the third one is by importing CSV file, like an Excel file, importing it into a record. So I will send us a video and send us the file to work with so that we can practice, we can use that to practice and see how we can, if we find ourselves in such a situation, we can know how to tackle that. Okay, do we have any question?